Good morning, students. So far we have learned about one-dimensional motion, but theoretically, okay. But to get compact and clear concept about it, we need something else. So that's why it is graphical representation of one-dimensional motion. So one-dimensional motion, we all know when motion takes place along straight line. So graphical representation is required over theoretical representation, because through graphical representation you will get a clear, minute and compact idea about one-dimensional motion. You may have some difficulties to understand about one-dimensional motion theoretically. Theoretically, it generally provides shallow knowledge. But today, through graphical representation, we will see how to understand about one-dimensional motion. After that, I think the one-dimensional motion, your knowledge about one-dimensional motion concept, everything will be clear. Okay. So let's see. Now the one-dimensional motion can be represented graphically by three ways. Okay, by three graphs. Okay, that is displacement or distance time graph, velocity or speed time graph, and acceleration time graph. But so far we have learned that displacement and distance is not the same thing, whereas velocity and speed is not the same thing. But here look at the term one-dimensional motion. It means when motion takes about a straight line, and we have already learned that if a body executes a curved path, only in that case distance and displacement is not same. It means when direction changes, then in that case also velocity and speed not same. But when a body moves in a straight line, it means there is no change in direction. So magnitude and direction not change. So in that case, isn't it? I just showed you through a straight line. Straight line means there is no curve, so distance and displacement is same. Velocity and speed is also same. So that's why displacement and time graph also means distance time graph. Velocity time graph also means speed time graph in case of straight line motion, that is one-dimensional motion. Clear? Now, at first we will discuss about distance and time graph. Clear? Now through distance time graph, okay, how will be benefited? How can we, what information can we get from here? Since we all know that velocity equals to distance by time, so through distance time graph we can calculate, determine, we can get the velocity of the body. Now there are so many conditions. So how to draw the graph? First of all, you need to know this. Now for all this kind of graph, okay, displacement time graph or velocity time graph, time is always plotted, that is taken along x-axis. Clear? You can see through time is in second, whereas displacement is drawn or plotted or taken along y-axis, in meter. Clear? Now when the body is at rest, so many conditions. Okay, so when the body is at rest or at stationary, so what will happen? Okay, obviously there will be no velocity, but how it can be represented graphically? Through diagram. Let's see. So time is plotted along x-axis and displacement is plotted along d-axis, along y-axis. D is represented, okay, D indicates displacement. Now we have, okay, divided through equal time, that is 1, 2, 3, 4, 5. Okay, each interval has to be equal. Along y-axis displacement 10, 20, 30, 10, 10, 10. Okay, 10 equal intervals. Okay, so it means a small division represents 1. Okay, so nothing else. So 10, 10, 10, 10, so 40. So clear? So when the body is at rest, a body is at rest means there is no external force is applied. So time glided by, day, month, year, the body will be at rest. So it means, suppose at 1 second, okay, at 0 second, body was at 30 meter distance, suppose. Okay, at some place. After 1 second, it is also at rest at 30. After 2 seconds, it is also at 30 meter. After 3, also same. It means rest. Stationary at rest means which doesn't change its position with time. So that's why at 0 second, 1 second, 2 second, it is at rest. So that's why all these are point. 0 second, 30, 1, 30, 2. It is still remain at rest. It is not changing its position. So it means, so we are getting all these points. So if we join this point, we will get a straight line AB. It is the distance time graph or displacement time graph. It represents AB, the straight line AB, which is parallel to which? to the x-axis, that is time axis. It denotes the displacement time graph. Okay, this is axis. So this is graph, a particular straight line AB for a body at rest. So velocity is 0, obviously. Okay. Now, so we have not got any velocity here. Let's move to the second condition. Now the body was at rest. Now, if the body is in uniform velocity. Uniform velocity means velocity is equals to distance by time. Sir, here distance by time or displacement by time. It means uniform, constant velocity. It means distance by time. If with equal time interval, it travels equal amount of distance. Let's see through graph. After 1 second, okay, in 1 second, its travel distance 10 meter, 2, okay, 20, 3 second, 30, 4 second, 40. So you can see at each and at the interval of 1 second, its velocity is increased by 10 meter, isn't it? So it means the velocity increases with equal time. Okay, if not velocity here, sorry, that is displacement. If it is displacement or distance increased, if distance increased by an equal amount with equal time of interval, in 1 second 10, the next 1 second also 10, so total 2 second 20, the next 1 second also 10, it's 30. Okay, so it means then in that case we will get all this point at 1 second 10, 2 second 20, 3 second 30. So if we join this point, we will get a straight line. Let's give a name, OD. A straight line passing through the origin O. Okay, isn't it? A straight line which represents, isn't it? The body is moving away, isn't it? From starting point, the body has started its journey from point O and it's moving away, isn't it? So how to find out? So how to find out the velocity of the body using this graph? Now since velocity is equal to d by t, so we have got here the straight line OB. Yeah, isn't it? OB or OD, whatsoever. OD. Okay. So now it is generally obtained by finding the slope of the straight line. Slope. Now how much it is inclined with x-axis and y-axis, isn't it? So slope of inclination. So here inclination means, okay, it makes an angle. When something is inclined to something, when something is inclined to over anybody, it makes some angle. So it makes some angle, suppose theta. So this is the slope, okay, inclination, isn't it? How much it is inclined, tilted. So it is generally found by finding the slope of the line. Suppose that we can take any point. So that's why it is double N circle. It means at 3 seconds we will find the velocity. So we will draw two perpendicular from B to X, one upon time axis and one upon displacement or distance axis, y axis. So suppose this represents O, okay, C. So now slope, what do you mean by slope? As I said, when it makes an angle with time axis. So here, since it's a bisector, you can just it is not the authentic, but how BC. So velocity V, since velocity is equal to distance by time, so distance means, so this is distance equal to, so distance, this is equal to BC divided by time. What is the principle? How we got BC? What is theta? Since we all know that, I don't know whether you have just reached up to that is tan theta. Tan theta equals to base, perpendicular by base. So when theta is equal to 45 degree, that is tan 45 degree equals to 1. So we can write, isn't it? Tan theta. So tan theta equals to, we can write BC divided by OC. Now when theta equals to 45 degree, so tan 45 degree equals to 1, isn't it? So just like that. So in this case theta, isn't it? Not we don't need any 45 degree else. So tan theta equals to B by C. When theta is very small, when theta is much small, so we can write theta equals to BC by OC. This is theta. Tan theta. Tan theta means the tangent of any angle is perpendicular by base when theta is small. So tan theta is equals to theta. So this is BC by OC. This is the slope. This is the, okay, this is the slope. This is slope all about, isn't it? Now how can we find the slope? Nobody understands. From which it is derived? From tan theta. So BC by OC. Clear? So what is BC? You can see. What is BC? This is 30. And what is OC? OC is 3 seconds. 1, 2, 3. So 3 by 30 is equal to 10 meter per second. So its velocity is 10 meter per second. So you can see that velocity can be easily determined using the displacement or the time graph or displacement or distance time graph. Clear? Now if the body now here slope is positive, here velocity is positive. It means the body is moving away from starting point. It may be in the upward direction. Okay, it means it's if its distance increases, isn't it? Moving away from starting point. If we release from starting point, it's moving away. If we throw, it's also to moving away. But if the body returns back to its original position, it means its starting point, then we can say its velocity is negative, isn't it? So let's see the next case, isn't it? So when the body strikes the wall and then returns back, clearly you can see, so velocity has to be negative. So let's see. So again, time is plotted along x-axis and displacement along y-axis. So time is equally divided 2, 4, 6, 8, 10, 12, 10 each. One thing, okay, keep it in mind, okay, very firmly, okay, paste inside the wall of your mind as well as inside your head, that is the interval should be equal, it should be uniform. If this is 2 seconds, if this cannot be 4 seconds, interval has to be equally divided along D also. So when a ball strikes the wall, what happens? So when balls, okay, so first line, straight line OA, it represents the ball is, isn't it? A ball is generally moving on a smooth floor. So it means it is moving away. Since the slope, okay, it represents the ball is moving away from the starting point. Okay, we will not say anything whether it is starting, okay, then it hit, then it will return back. So obviously since the ball is hitting a wall, so it will convert, it will just transfer some of its energy to the wall. Frictionless, very smooth whatsoever. Then returning back, its velocity will be slightly less. We will see here. So when the ball is moving away from its starting point, it means when it moves. So then we can see, okay, at 2 seconds it covers 20 meter, then at 4 seconds it's 40, then at 6 seconds it travels 60 meter. So what is the slope of the OA? Again, slope of the line OA, we have to draw, this is theta. So tan theta is equal to perpendicular by base, that is, this is 60 divided by 6 seconds. What is the time? It's travels 60 meter. What is the, in which time interval? 6. So 60 by 6 is equal to 10 meter per second. So we can see slope is positive, there is no negative value. Clear? There is no negative value. So that's why it means the body is moving away from its starting point. Let's see the slope of AB when it hits the wall and then moves back. Then in that case, velocity, since it is moving in the down, okay, it is in the downward direction. So again, slope in this case from this triangle, isn't it? From this triangle. Initially, it is over, it is away, but now we got this, okay. Now it is moving down, and in 40 seconds, it hits the wall, then return back to the original position, and it takes 14 seconds to come towards absolute rest. It means at 40 seconds, its velocity is, okay, at 40 seconds, it comes at stop. At 40 seconds, its distance covered is 0. So we'll find its velocity. So velocity, it is again, now its inclination. Now here, see, it is theta 1, it is theta 2. So now its slope. Okay, now at first slope OA, now slope AB, tan theta is equal to perpendicular by base. So it is again 60. Okay, again 60, but here we can write this is 0 minus 60, isn't it? A minus sign, since it is in opposite direction. So minus 60 divided by time. Initially it was 6 seconds. Why? 0, 6. 6 minus 0 is equal to 0. But here, when it reaches at the top or when it hits the wall at t is equal to 6 seconds, exactly at t is equal to 6 seconds, it hit the wall. Then at 40 seconds, it returned back and, okay, comes absolutely at rest. So what is the time? 14 seconds minus 6 seconds. Very clear. So 40 minus 6, 8. So here, we can see there is a negative sign. Obviously there will be a negative sign because initially it was just moving towards the wall and then after hitting the wall it turned back. So since it's a vector quantity, this okay, since vector is a velocity is a vector quantity, so obviously its direction, since it is displacement also, isn't it? It is moving in one direction. Then as I showed through a, what's it? Already I have generally shown through a picture, that is AB. If you move from A to B and then if it returns back anybody from B to A, obviously it will be negative. So this negative sign indicates that the body is just returning back to its original position. Clear? Okay. Now moves on to fourth condition. What happens if neither happens? Neither at rest, uniform velocity, neither strike the wall. If the body moves with variable velocity. Variable velocity means it can travel at any distance. Its value of traveling the amount of distance is not equal with equal time of interval. Suppose in 1 second it's 10, 2 seconds 15, in 3 seconds then 45, then 5 seconds 60. It means arbitrary. You can see. Okay. So again time is plotted along x-axis, y is along. So velocity with variable velocity means which doesn't cover equal amount of distance with equal interval of time. You can see in 1 second suppose, okay, you can see at 2 seconds it travel, isn't it? 2 seconds it travel 10, then 4 seconds it 25, very clear. In 6 seconds 40. So like this. So you will, if you divide 10 by 1 is equal to 10, 25 by 4 is not 10, okay, 40 divided by 6 is not 10, so it means velocity changes. It is not covering equal amount of distance with equal amount of time which was happening in this case, isn't it? So how to find out, okay, the velocity in this case, since velocity is variable, so in this case you can see obviously the line will not be straight line, it will be a curved. It will be a curved line. So how to find out the velocity in this? We will take a particular point and we will just draw a tangent. Here we have drawn a tangent passing just the point D. At point D it indicates at 4 seconds the body travels 25 meter. So we will have to find the velocity of the body at 4 seconds, or if we in terms of second, if we say that is the velocity of the particle at 4 seconds. Or if you want to express it in terms of distance, it means its velocity when it travels 25. Since you can see the dotted line is in between 30 and 20, it represents 25 meter. So how to find out? So we have drawn a tangent. Okay. In this, so BC and AB, so this is 6 seconds. So the slope of AC, slope of line AC, clear? Again it is, we can find this theta. So tan theta equals to BC by AB. So what is BC? So this is 40 from graph, it is clearly visible. 40, so BC is equal to this distance minus this distance, so 40 minus 10. What is the time interval? Okay, here time represents AB, means this is already 3 and after 3 seconds, so 6 minus 3 is equal to 30 by 3, this is 10 meter per second. So this is at t is equal to 4 seconds, or when the body travel at distance 25. If we want to find 5, we will see velocity will be different because it will have to be different. Why? It's the curved line. So if we find slope at this point, we will see the velocity will be different. Why? Because time will be different, distance will be different. So that's why it's moving with variable velocity. So what we have learned from this graphical representation of one-dimensional motion from displacement distance time graph, it means if a body is at stationary, first of all from displacement or distance time graph, since it's one-dimensional motion, no change in direction, so that's why displacement equals to distance. So from distance and time graph, what can we get? What information can we acquire? That is the velocity. How? By finding the slope. Okay. So if the body is a stationary or at rest, the displacement time graph is a parallel line, is a line parallel to the time axis, no velocity. If the body is in uniform velocity, moving with uniform velocity, then displacement time graph will be a straight line passing through the origin. Clear? It means its slope is positive, velocity is positive, slope is positive, and the body is moving away from the starting point. If any body moves to a particular direction and then strikes and then return back to its original position, in that case the velocity time graph for the forward direction, it will be above, okay, straight line, okay, and if it means in that case velocity, the slope will be positive, and if it return back, it will be also a straight line, but in that case its slope will be negative, which will represent negative velocity. It means it is in the opposite, it is just returning back. If the body moves with variable velocity, means it attains unequal distance with equal time of interval, okay, then in that case we will get a curved line. The velocity time graph will the displacement time graph will be a curved path, and through any point, if we find through the slope, we will get different velocities. Clear? In the next video, very next two videos, we will see the graphical representation, that is the velocity or speed time graph. Clear? And then acceleration time graph.